Hello, all. Welcome to day 27 of the daily case study series for CBSE Grade 12. The question goes like this: Arka bought two cages of birds. Cage 1 contains 5 parrots and 1 owl, and cage 2 contains 6 parrots. One day, Arka forgot to lock both the cages, and two birds flew from cage 1 to cage 2 simultaneously. Then, two birds flew back from cage 2 to cage 1 simultaneously. Assume that all the birds have equal chances of flying. On the basis of above information, answer the following questions. So, before we answer the questions, let us analyze the various cases in which the birds are flying from cage 1 to cage 2 and cage 2 to cage 1. Case A: two parrots fly from cage 1 to cage 2. So when this happens, in the first cage, we will have three parrots alone and zero owls have moved. So we will have one owl there in the first cage. In the second cage, the count will become eight parrots. Assume two parrots fly back from cage 2 to cage 1. Then in cage 1, we will have five parrots, one owl, and six parrots in the second cage. Case B: assume one parrot and one owl fly from cage 1 to cage 2. In that case, in the first cage, we will have four parrots and zero owls. And in the second cage, it would have become seven parrot and one owl. Assume one parrot and one owl come back from cage 2 to cage 1. In that case, in cage 1, we will have five parrots and we will have one owl. In cage 2, it will be six parrots only. Case C: assume one parrot and one owl flew from cage 1 to cage 2. So in this case, what happens? The cage 1 will have four parrots and zero owls. In cage 2, it will be seven parrots and one owl. Now let's assume two parrots are coming back from cage 2 to cage 1. So in cage 1, we will have six parrots, but the owl has not come back here. So in second cage, we will have five parrots and one owl. So these are the three cases in which this is going to happen. Now let's find out the number of possible ways these cases happen. For case A, number of possible outcomes, that is n of A will be equal to, so in cage 1 we have five birds, in that two parrots are flying, so it will happen in 5C2 ways. One owl is there but it did not fly at all, so it happens in 1C0 ways. Then from cage 2 to cage 1, there were 8 parrots in cage 2. So 2 parrots are coming back. So that happens in 8C2 ways, which is equal to 5 into 4 by 2 into 1 into 8 times 7 by 2, which is equal to 280. So the entire event of two parrots flying from cage 1 to cage 2 and cage 2 to cage 1 happens in 280 ways. Now let's calculate for case B. In case B, number of possible outcomes is equal to n of B. So let's figure out what's happening in case 2. One parrot and one owl is flying from cage 1 to cage 2. So out of 5, one is flying, so it happens in 5 C1 ways. And then one owl is flying, it happens in 1 C1 ways. And while coming back in cage 2, we have 7 parrots. So one parrot comes back, one owl comes back. So 7 C1 ways into 1 C1 ways, which is equal to 5 times 1 into 7 into 1, which is 35. So number of possible outcomes for the case B is 35. Next is case C. In case C, number of possible outcomes, that is n of C, is, so one parrot, one owl flew from cage 1 to cage 2. That is, it happens in 5 C1 ways into 1 C1 ways into from cage 2 to cage 1. 7 parrots are there in cage 2 and one owl is there. While coming back, only 2 parrots are coming. So it happens in 7 C2 ways, and for owl it is 1 C0 ways, which is equal to 5 into 1 into 7 into 6 by 2 into 1, which is equal to 105. So number of possible outcomes for case C is equal to 105. Now that we have done all these, let's go back to the question. Subdivision 1 says, when two birds flew from cage 1 to cage 2 and two birds flew back from cage 2 to cage 1, find the probability that the owl is still in cage 1. In case A, only 2 parrots flew from cage 1 to cage 2. So owl is there in the first cage only. And while coming back, same 2 parrots have come back. So it has happened in A. That is owl staying in cage 1. Then case B. One parrot and one owl flew from cage 1 to cage 2, but it has returned. The owl has returned from cage 2 to cage 1. In case B, also the owl is in cage 1. With C, one parrot, one owl flew from cage 1, but while coming back, the owl did not return. Only 2 parrots have returned. So C cannot be taken here, since the question is asking only for the probability where the cage 1 has the owl. Therefore, total possible outcomes is equal to 280 from case 1 plus 35 from case 2 plus 105 from case 3, which is equal to 420. Then probability that the owl is in cage 1 is equal to favorable outcomes divided by possible outcomes. The case A and case B are favorable. That is 280 plus 35 upon 420, which is 315 by 420, which gives us 3 by 4. Now subdivision 2. When two birds flew from cage 1 to cage 2 and two birds flew back from cage 2 to cage 1, the owl is seen in cage 1. Okay. Now what is the probability that one parrot and one owl flew from cage 1 to cage 2? Now this is a conditional probability type of a question. The condition has been given. The condition is let's call it as E1. The condition says two birds flew from cage 1 to cage 2, and again two birds flew from cage 2 to cage 1. After all this happens, then also the owl is in cage 1. So that is the condition. The question is asking us to figure out the probability of what is the probability that one parrot and one owl flew from cage 1 to cage 2. One parrot and one owl. In which cases is this happening? Case B, one parrot and one owl is flying from cage 1 to cage 2. Similarly, in case C also, one parrot and one owl is flying from cage 1 to cage 2. Okay, so we have to consider these. But we will apply that condition that is given to us, and then we will cut short what is not needed for us. Let E2 be one parrot and one owl flew from cage 1 to cage 2. So we have to find the probability of E2 when E1 has happened. Find out P of E2 given E1. By Bayes' theorem, P of E2 given E1 is equal to P of E1 intersection E2 by P of E1. Now in this, P of E1 refers to the two birds flying from cage 1 to cage 2, cage 2 to cage 1, and still owl is there. So that is what we figured out in the first subdivision. That is, P is in the cage 1. So P of E1 is equal to P of owl in cage 1, which is equal to 3 by 4. Now coming to P of E1 intersection E2. That is again, try to understand the E1 and E2. Two birds fly from cage 1 to cage 2, cage 2 to cage 1, and the owl is there in the first cage. E2 says one parrot and one owl should have gone from cage 1 to cage 2. So according to that, we saw there are two cases, B and C. Okay, in B, if we notice, after this flying scenario has happened, we have five parrots and owl in the cage 1. That is, owl is there in the cage 1. But in case C, one parrot and one owl has gone from cage 1 to cage 2, but it never came back. So after this event happening, the owl is not there in the cage 1. So we cannot take the C case. Fine. So then P of E1 intersection E2 is nothing but P of B. P of B is N of B by total outcomes, possible outcomes, which is 35 by 420. Now P of E2 given E1 is equal to 35 by 420 by P of E1 is nothing but 3 by 4. On simplifying this, 35 by 420 times 4 by 3. We get 1 by 9. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.